Welcome to The Explainer. I am absolutely thrilled to have you here today because we're about to unpack a massive wave of updates hitting the Java ecosystem this May and June of 2026. Think of your enterprise Java stack kind of like building a house. Over the next few minutes, we're going to look at how every single level of that house, from the deep structural foundation all the way up to the flashy smart home tech in the roof, is getting a major simultaneous upgrade.
Okay, let's just dive right into this, shall we? Is your enterprise Java stack truly prepared for the great shift of 2026? What makes this exact moment in the Java ecosystem so incredibly fascinating is the sheer volume of changes happening all at the exact same time. We're seeing immense shifts starting right down at the bedrock of the JVM layer, rippling out through community licensing, touching some absolutely critical security frameworks, and then extending all the way up to cutting-edge AI integration. The stakes for engineering teams right now are, frankly, incredibly high.
Here's our roadmap for making sense of it all today. We'll start at the bottom by modernizing the Java foundation. Then, we'll look at the framing of our house with the Spring Boot 4.0 shift. After that, we'll inspect the security system by tackling zombie dependencies. Next, we'll examine the broader neighborhood with the OpenJDK migration wave, and finally, we'll install that smart home tech by unleashing agentic AI. Let's get started. All right, Section 1, Modernizing the Java Foundation. We are starting right down at the foundation. These OpenJDK 27 enhancement proposals, or JEPs, represent a structural, heavy-duty upgrade to the hotspot JVM. Now, historically, the JVM dynamically selected its garbage collector based on your hardware, right? And it often defaulted to the serial collector for small cloud containers. Well, JEP 523 establishes the high-performance JWone garbage collector as the universal default. Combine that with JEP 534, which makes compact object headers the default behavior, and you're looking at some serious optimizations for lightweight containerized microservices. We've also got the Vector API continuing its incubation while it waits for Project Valhalla, and PEM encodings finally finalizing their cryptographic APIs. What this actually means in practice is that the platform is naturally adapting to modern hardware density. By bringing concurrent compaction and significantly shrinking the physical memory footprint through these JEPs, your small cloud containers are getting a massive efficiency boost. And the absolute best part? You don't even need to touch your application code to see the benefits. It just works. Oh, actually, a quick operational heads up though. Maintenance for the macOS x64 port is officially ending with JDK 27, so you'll definitely want to plan your infrastructure updates around that. Moving right along to Section 2, the Spring Boot 4.0 shift.
So, moving one layer up to the framework level, this is essentially the framing of our house. This timeline really injects a sense of data-driven urgency into everything we're discussing today. Just look at how insanely tightly packed these critical milestones are. We just hit the JDK 27 JEP updates on May 19th. Then right around the corner on May 28th, we get the general availability release of Spring AI 2.0. But looming right behind that, on June 30th, is a massive cliff, the official end of life for Spring Boot 3.5 and Spring Framework 6.2.
Now, what's really interesting here is the stark contrast between the old stack and the new stack. Moving to Boot 4.0 is a genuine major version increment. You're looking at a new Java 21 recommendation and the widespread adoption of JSpecify for strict portfolio-wide null safety. But there's a trapdoor, and that's the jump from Jackson 2 to Jackson 3. It changes default behaviors around date serialization and property ordering. Seriously, if you don't test this thoroughly, Jackson 3 is going to be the silent assassin that breaks your API payloads in production.
Which naturally leads us to Section 3, Zombie Dependencies and Security. To really grasp the risk here, we have to talk about zombie dependencies. Think about it like this. These are transitive libraries tucked deep inside those end-of-life frameworks. Once the core framework hits EOL, the main project stops issuing security patches. But those underlying libraries? They just continue to silently collect active vulnerabilities over time. It's a pretty terrifying reality, because even if your own application code hasn't changed at all and it feels perfectly stable, those unpatched underlying libraries are leaving your entire enterprise system wide open to attackers.
The raw stats from the May 2026 patch cycle impart just how alarming this situation really is. We're talking about 24 unique upstream CVEs that are fully reachable through standard legacy Spring Boot bills of materials. And look at the severity of these Thymeleaf vulnerabilities. CVS scores of 9.1 and 9.0. Those are critical drop-everything red alert emergencies. We're talking server-side template injections that lead straight to remote code execution, which essentially hands attackers the keys to the kingdom. Toss in some legacy Hazelcast and Log4j bugs still lurking around in unpatched stacks, and you can clearly see why clinging to an EOL framework is just a massive compliance nightmare.
So how on earth do we navigate this tension? Well, the practical resolution is what we call a parallel track approach. Step 1, secure your June 30th EOL exposure immediately by implementing a solution like HeroDev's never-ending support. That gives you active patch monitoring so the app stays secure today. Then, Step 2, deliberately plan your Spring Boot 4.0 migration. Guys, please do not rush a complex architectural upgrade into a tiny 33-day window just to beat a calendar deadline. Rushing causes production incidents for sure. Secure the baseline first and then migrate at a pace that actually makes sense for your team.
Let's pivot slightly to Section 4, the Open JDK Migration Wave. So transitioning to the operational layer of the enterprise ecosystem, the crucial point here is this massive industry-wide momentum shifting right before our eyes. According to Azul's 2026 State of Java survey, an absolutely staggering 81% of organizations are either actively migrating or planning to migrate off Oracle Java to an Open JDK distribution. Only 19% are staying put or are still undecided. Think about that for a second. That is a fundamental reshaping of the entire Java landscape. And what exactly is driving that massive 81% shift? Well, it mostly comes down to this number right here, 92%. 92% of surveyed organizations are concerned with Oracle's pricing structures and their seat-based licensing models. On top of that, 21% of these organizations have already faced a formal audit. So this potent combination of intense cost pressure and looming compliance risk has created this huge urgency for enterprises to adopt open-source alternatives like Azul, Payara, and other community builds.
But you know, migrating your JDK isn't just waving a magic wand. Connecting this back to your day-to-day reality, as Simon Ritter from Azul points out, the transition is no longer a simple drop-in replacement task. Teams must navigate compatibility testing and establish reliable patch management pipelines. Migrating takes actual, deliberate operational strategy. You've got to plan around deprecated features, lock down your deployment pipelines, and thoroughly verify that your new OpenJDK vendor is actually going to provide reliable critical set updates.
Which pivots our narrative to a really important question. Why go through all this migration pain, right? If updating the JVM, handling complex OpenJDK licensing, and carefully refactoring code for Spring Boot 4.0 requires so much exhausting engineering effort, what is the ultimate reward for doing all that hard work?
And that brings us to Section 5, Unleashing Agentic AI. The ultimate reward is the very top layer of our architectural analogy. It's the smart home tech where your modernized stack finally unlocks some mind-blowing next-generation capabilities. By doing the hard work to get onto Boot 4.0 and JDK 27, developers are now able to seamlessly weave large language models and semantic search right into their existing Java business logic. We've got Spring AI 2.0 dropping on May 28th, which gives us a stable, production-ready advisor framework and vector store abstraction. We also have Oracle AI Database 26 AI, which introduces native AI vector search directly in the database engine itself. And when you add in integrations for Google Vertex AI and the Model Context Protocol, your traditional Java backend can suddenly act as a highly intelligent, context-aware AI agent.
Let's make this concrete and look at how this builds into an actual deployment strategy. At JavaOne 2026, Dmitry Polyakovsky presented a brilliant, super practical way to architect these agentic systems. By layering internal caffeine caches for ultra-low latency alongside distributed Redison or Valkey caches for shared application state, and utilizing semantic vector searches, enterprise teams can drastically reduce expensive LLM API calls and latency. You aren't just blindly pinging OpenAI and racking up a bill. You're architecting a highly performant, incredibly cost-effective smart system.
Which leaves us with this final thought for the day. Your enterprise Java stack is modernizing from the absolute bottom of the JVM all the way up to agentic AI orchestration. The new tools are incredibly powerful, yes, but those security deadlines are very real. So will you deliberately ride this wave of innovation, or will your applications be crushed by the June 30th end-of-life cliff? It's a truly crucial time to assess your enterprise portfolio. Thank you so much for hanging out with me on this explainer. I really hope this helped map out a clear path forward for your team, and I will see you on the next one.